A warm, glorious afternoon to all. First of all, let me introduce myself. My name is K. Rahul. I hail from Damarcheru Tanda. I am a student of 10th class at the TTWREIS Boys, Jinnaram. Welcome to the session of mathematics class. We might have heard a word usually that is number. Did you know what is number, how it is originated? Before we begin to discuss the historical development of real number system, clear evidence that this is not so is the fact that the concept of number has changed greatly throughout the development of mathematics up to the present day. Why do we call something a number? Well, perhaps because it has a direct relationship with several things that have hitherto been called a number, and we extend our concept of number as a spinning thread with twist fiber on fiber. In ancient times there was no number. How they calculated? Here is interesting story. Let's we discuss. In a village there was a shepherd's family, father, mother and son. Father has 10 sheep. One day shepherds called the son and told to take the sheep into the forest for grazing, and he gave 10 stones for each sheep, and sons took the sheep into the forest with stones, and he returned in the evening and allowed the sheep into the hut by dropping the stones. He done same thing in the next day. One day leopard attacked on one sheep and caught the same whenever they were in the forest. In evening, as usually, shepherd's son allowed the sheep into the hut by dropping the stones. Surprisingly, one stone has been left. He noticed that one sheep has been missed. Like this, either in ancient times or present times, number took most important role in human life. Did you guess today's my topic? Yes, today my topic is real numbers. In this topic, in this class, you are going to study about the natural numbers, whole numbers, integers, rational numbers, irrational numbers and real numbers. Now firstly, natural numbers. After struggle of many years, in above story you count that number of sheep is there, number of sheep is missed. Like this, a set of counting numbers are called natural numbers. It is denoted with black bold letter n. The examples of natural number are 1, 2, 3, 4, infinity. And we count that number of candidates in your family. Yes, number of candidates in your family. We count the number of candidates in your family and number of students in your institution. Yes, we count the number of students in your institution. Like this, a set of counting numbers are called natural numbers. After many years like this, mathematicians after came into existence of addition, subtraction, multiplication, division, mathematicians get a doubt. If 2 plus 2 is equal to 4, then what is the value of 2 minus 2? 3 plus 3 is equal to 6, then what is the value of 3 minus 3? 5 plus 5 is equal to 10, then what is the value of 5 minus 5? 10 plus 10 is equal to 20, then what is the value of 10 minus 10? After struggle of many years, a great mathematician Aryabhatta found that 2 minus 2 is equal to 0, 3 minus 3 is equal to 0, 5 minus 5 is equal to 0. So, in adding 0 to the set of natural numbers, we get a new set of numbers called whole numbers. Adding 0 to the set of natural numbers, we get a new set of numbers called whole numbers. These whole numbers are denoted with black bold letter W. The examples of whole number are 0, 1, 2, 3, 4, infinity. Now, did you find any difference between natural number and whole number? Yes, all natural numbers are whole numbers, but all whole numbers are need not to be natural numbers. Except 0, all whole numbers are natural numbers, but including 0, all whole numbers are need not to be natural numbers. Next, like that, a great mathematician Leopold Kronecker says that God made the integers, the work is the work of man. After given this quotation, many mathematicians get another doubt. 2 plus 3 is equal to 5, then what is the value of 2 minus 3? 2 plus 5 is equal to 7, then what is the value of 2 minus 7? 3 plus 5 is equal to 8, then what is the value of 3 minus 5? 3 plus 8 is equal to 11, then what is the value of 3 minus 8? After struggle of many years, mathematicians found that there is a set of negative numbers is also there. 2 minus 3 is equal to minus 1. 2 minus 5 is equal to minus 2. 3 minus 8 is equal to minus 5. Like this, including negative numbers to the set of whole numbers, we get a new set of numbers called integers. So, including negative numbers to the set of whole numbers, we get a new set of numbers called integers. In integers, we have positive integers. Positive integers mean all the positive numbers 1, 2, 3, 4, 5, infinity. All are the positive integers. Did you find here all natural numbers are also positive integers? Next, negative integers. What are the negative integers? All the negative numbers are all the negative integers. Minus 1, minus 2, minus 3, minus 4 are the examples of negative integers. Did you see here? Minus 1, minus 2, minus 3, all are the examples of integers, and those are the examples of positive integer. Now, in both case, in positive integer and in negative integer, did you find anything? Yes, here 0 is neither nor positive nor negative. Next, non-negative integers. Non-negative integers mean integers which are not negative are called non-negative integers. Example 0, 1, 2, 3, 4, infinity, all the examples of non-negative integers. Did you find anything here? Yes, all whole numbers are non-negative integers. So, adding all these sets of number, we get integers. Integers are denoted with capital I or Z. In integers, we have negative numbers, positive numbers and 0. In before, we know what are the uses of positive numbers, but in integers we have negative numbers also. So, what is the use of these negative numbers? Yes, the use, we also use negative numbers in our daily life. In measuring below sea level, we use negative numbers. When we measure downwards, we use negative numbers, and when we measure temperature in Fahrenheit, in Kelvin, in Celsius, whatever it, we use negative numbers to, when we measure, we get negative numbers also. Like this, negative numbers are also most important in our life. Next, rational numbers. So, what is a rational number? A rational number is a number which is in the form of p by q, where p comma q are belongs to integers and q is not equal to 0, is called a rational number. A rational number is denoted with capital Q because Those are called quotients in German. That's why rational numbers are denoted with capital Q. What is a rational number? A rational number is a number which is in the form of P by Q, where P comma Q are belongs to integers and Q is not equal to 0. Now take example 2 by 3. 2 by 3 is a rational number because 2 by 3 is a form of P by Q and 2 comma 3 are belongs to integers and 3 is not equal to 0. Take another example, minus 1 by 2. Minus 1 by 2 is also a rational number. Minus 1 by 2 is a form of P by Q and minus 1 or 2 belongs to integers and 2 is not equal to 0. Next, all natural numbers are also rational numbers. Take any natural number example, 2 is a natural number. So 2 is also written as 2 by 1. 2 by 1 is a form of P by Q and 2 comma 1 are belongs to integers and 1 is not equal to 0. So all natural numbers are also rational numbers. Next, whole numbers. All whole numbers are also rational numbers. Take whole numbers, any example, 0. Isn't it 0 rational number? Yes, 0 is also a rational number because 0 is written as 0 by 1. Here P equal to 0 and Q equal to 1. So 0 by 1 is a form of P by Q and 0 comma 1 are belongs to integers and 1 is not equal to 0. So all whole numbers are also rational numbers. Take another example, integers. Take negative number minus 8. Isn't it minus 8 is also a rational number? Yes, minus 8 is also a rational number. Minus 8 is written as minus 8 by 1. Minus 8 by 1 is a form of P by Q and minus 8 and 1 are belongs to integers and 1 is not equal to 0. So all negative numbers are also rational numbers. Next, take example, all fractions. All fractions are also rational numbers. Take fraction, any 2 by 3 is a fraction. 2 by 3 is also a form of P by Q and 2 comma 3 are belongs to integers and 2 is not equal to 0. Next, I ask one question, isn't it root 4 rational? Yes, root 4 is also rational. All perfect square root numbers are also rational numbers. So take any perfect square 4. 4 is a perfect square. So isn't it root 4 rational? Yes, root 4 is written as root 2 square. Square root get cancelled, then we remain 2 by 1. 2 by 1 is a form of P by Q and 2 comma 1 are belongs to integers and 1 is not equal to 0. Take another example, root 9. 9 is a perfect square number. So root 9 is also a rational number because root 9 is written as root 3 square. Square root get cancelled, then we remain 3 by 1. 3 by 1 is a form of P by Q and 3 comma 1 are belongs to integers and 1 is not equal to 0. Like this, all perfect square root numbers are also rational numbers. Next, all terminating numbers are also rational numbers. Take terminating decimal 3.2. So firstly, what is terminating decimal? Yes, a terminating decimal is a decimal. A decimal number which terminates is called terminating decimal. So all terminating decimals are also rational numbers. Take a terminating decimal 3.2. 3.2 is a terminating decimal. Now express 3.2 in the form of P by Q. So how can we write in the form of P by Q? Yes, 3.2 is also written as 32 by 10. Next, another example, 1.2. 1.2 is a terminating decimal express the 1.2 in the form of P by Q. So 1.2 is also written as 12 by 10. Next take next all terminating repeating decimals are also rational number. So what is all terminating? So a terminating decimal is decimal numbers are repeating or recurring decimals. Then the given decimal number is a form, we also write in the form of P by Q. So take example 1.6262626262. 62 will not terminate at a value, but 626262 are repeating or recurring decimals. 1.55555555. 5 will not terminate at value, but 5 is repeating and recurring decimal. So like this, non-terminating, repeating or recurring decimals are also a rational number. So it is total fact about rational numbers. Next, irrational numbers. So first, what is an irrational number? A irrational number is a number which is in the form of P by Q, which is in the not form of P by Q, which is in the form of P by Q is called rational number, which is in the not form of P by Q is called irrational number. So a number which is denoted with Q dash or capital S. What is irrational number? A number which is in the not form of P by Q is called irrational number, and it is denoted with Q dash or capital I. The examples of irrational number is root 3, root 7, root 5, root 8, all the not perfect square root numbers are also the irrational numbers, and non-terminating, non-repeating decimals are also irrational numbers. Now what is non-terminating, non-repeating? A decimal number which has decimal numbers are non-terminating and those numbers are non-repeating, they are randomly numbers. Those are also irrational number. Example, pi. Pi is a irrational number. Pi is a non-terminating and non-repeating decimal because it has not exact value. You may have doubt that pi is a form of, pi is also written as 22 by 7. 22 by 7 is a form of P by Q, and 27 comma 7 are belongs to integers, and 7 is not equal to 0. Sorry, pi has not exact value. 22 by 7 is a approximate value. 3.14 something 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 we get. So it has non-terminating and non-repeating decimals. That's why pi is also a irrational number. Next, now if Q is a rational number and S is a irrational number, then the sum of rational number plus irrational number is also a irrational number. Now take example Q. Let Q equal to 2. Rational number is equal to 2 and irrational number is equal to root 2. So now Q plus S, 2 plus root 2. 2 plus root 2 is also a irrational number. So there is always the sum of rational and irrational number is always irrational number. Next, another one, Q minus S. The rational number minus irrational number is also the irrational number. So take rational number example 3 and irrational number root 3. So Q minus S equal to 3 minus 3 root 3. So 3 minus root 3 is also the irrational number. So the subtraction of rational number minus irrational number is also the irrational number. Now third one, the multiplication of rational number into irrational number is also the irrational number. Take now rational number Q equal to 2 and irrational number root 5, S equal to root 5. Now multiply the 2 into root 5. So 2 into root 5 we get 2 root 5. 2 root 5 is also the irrational number. Next, another law, the division of rational by irrational number is also the irrational number. Now take rational number is 10 or equal to, and irrational number is equal to root 5. Division of rational by irrational number is 10 by root 5. When we rationalize the denominator, 10 root 5 by root 5 by 5, we get 2 root 5. The final value at last we get 2 root 5. 2 root 5 is also the irrational number. So the division of rational into irrational number is also the irrational number. Once if Q is a rational number, S is a irrational number, the sum of Q plus S is also a irrational number, the subtraction of Q minus S is also the irrational number, and the multiplication of rational into irrational is also the irrational number, and the division of rational into irrational is also the irrational number. So it is all about the irrational numbers. Next, real numbers. So what are the real numbers? The union of rational and irrational number is called real number. The union of Q and Q dash is called real number. In Q V contains n subset W, W subset Z, Z subset Q, and another group we have Q dash. So all natural numbers are whole numbers, all whole numbers are integers, all integers are rational numbers. So all rational numbers and irrational numbers are called real numbers. These real number is denoted with capital R. The examples of real number is 2 root 5 minus 2 by 7 pi are the examples of real number. Next, we summarize what we learn in this class. Firstly, natural numbers. A set of counting numbers are called natural numbers. It is denoted with blackboard letter n. And second one, whole numbers. Adding 0 to the set of natural numbers, we get a set of numbers called whole numbers. It is denoted with letter W. Next, integers. Including negative numbers to the set of whole numbers, we get a set of numbers called integers. In integers, we have positive integers, negative integers, and non-negative integers. And thirdly, next, rational numbers. What is a rational number? A number which is in the form of P by Q, where P comma Q r belongs to integers and Q is not equal to 0 is called a rational number. Example, 2 by 3, 1 by 4, root 3, root 4, root 9 and minus 1 by 2 are the examples of rational number. Next, irrational numbers. Irrational numbers, a number which is in the not form of P by Q is called irrational number. A number which is in the form of P by Q is called rational number. A number which is in the not form of P by Q is called irrational number. The examples of irrational numbers are root 3, root 7, root 5, pi, 1.1236, non-terminating decimals are the examples of irrational numbers. Next, real numbers. So what are the real numbers? The union of rational and irrational number is called real number. The union of rational and irrational number is called real number. Real numbers are denoted with capital R. Next, next conclusion. The real life applications of real numbers are, if when we drive a vehicle, we go with a speed. A speed is also has a numerical value obtained by measuring distance and time, and we measure weather conditions, air temperature, wind speed and direction nature. And also the favorite students rockstar contact lenses dimensions and aeroplane flight deck instruments, altitude, speed and car driving instruments, dashboards and engine temperature are the real life applications of real numbers. And also distance traveled by ships, trains are also measured, we get numerical values. And we use geometry, trigonometry in the recreational sports, and we use statistics in our daily sports, and we use measurements in the cookbooks. I finally conclude with a quote: open your books with concentration and close your books with confidence. I hope you got my class. I thank our supreme hero Dr. R.S. Praveen Kumar sir for providing such a wonderful opportunity, and I thank my guide teacher Sri Vai Gopal sir. Thank you. Happy learning.